Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Question 25 states that uranium-235 fissions into 2 fragments plus 3 neutrons. Shown with this reaction here. These 2 blank spots are not provided, but we are told that they are 2. The mass, it tells us the mass of the neutron and the mass of uranium, and it states that if 220 MeV of energy is released, what is the total mass of the 2 fragments? So because we're dealing with mass-energy relationships, we know that the expression that we want to use for this scenario is that the energy released is equivalent to mc squared, where maybe more correctly I should put it's the change in mass. Change in mass times c squared. So we're trying to solve the mass of these 2 terms, which I'm just going to call it capital M. So if we want to look at the change in mass, maybe let's do it over here just for a little bit of an aside. We look at the mass on the right-hand side minus the mass on the left-hand side, the change in mass. So we see that's capital M plus the mass of 3 neutrons. So I'm going to call that 3 little m n. And then we subtract off the mass of 1 neutron, and we subtract off the mass of uranium, mu. Oh, actually, I'm going to do it from left to right in this scenario, but although it should not matter, I'm going to do it that my change in mass goes from the left-hand side to the right-hand side. So that means I have the mass of my neutron plus the mass of uranium and that's the left-hand side, so we minus off big M minus 3 times the mass of the neutrons. And by rearranging, I can find that my expression for this mass in terms of the change in mass of the reaction is simply the mass of uranium minus 2 times the mass of a neutron minus this delta mass, the delta change in mass. Okay, so now I have mu, I have 2mn, but I don't really have an expression for change in mass, or do I? Answer is yes, yes I do. It states that 225 MeV of energy is released. So that means if I rearrange this equation here, delta M is simply my energy over c squared. If it's released 225 MeV. Over c squared. Well, I don't want energy in terms of, I don't want mass in terms of energy per c squared, although it technically is a valid, as we'll find in elementary particles, it is a valid expression. However, I need something in terms of mass because I'm going to use it in this expression here. So if I want to get rid of MeV, I can divide this term by my energy to mass conversion factor, so 931.5 MeV, it's per c squared per u. So my double checking my units, my c squareds cancel, my MeV cancels, and I do have units of u, and I find that would simplify, or I guess calculate down to about 0.2415 u. So now I can put this into my expression here, in which I find my mass for my 2 fragments is 235, as given to us in the question, but if not, you could look it up in the back of the textbook or anywhere online. 0.043924 minus 2 times the mass of a neutron, 1.008665, minus this delta mass term, 0.2415. This whole expression has units of u. So we'd find that after performing this calculation, we would have a total mass size of 232.785 u. So there you go.